Okay, this is the instruction for lesson 8-1, where we began solving quadratic equations using the quadratic formula. In the video for lesson 8.0, I described why we might use the quadratic formula and talked about all of the other ways that we know how to solve quadratic equations. So that's worth referencing to kind of get an idea of why we're doing this. But today, let's just go ahead and practice solving this. So oftentimes I teach you sort of the intrinsic, or let's see, the theological way to sort of understand a problem and do it. But when we're using a formula, we really just want to follow the step-by-step process. So what we want to do first is to make sure that the equation is in standard form. At the beginning of first quarter this year, we practiced putting things in standard form a lot. Like if we had something like 5x to the fourth plus 2x to the third minus 6x plus 1, right? The idea is that we're writing this in the order of variables exponents, of the exponents decreasing. So the biggest exponent is listed on the left, and then as we head to the right, there's smaller and smaller exponents. Hopefully you remember doing some of that our first couple of weeks of the year. So we want these written in standard form. Our largest exponent is going to be second power, always. And if we don't have something to the second power, then it's not a quadratic equation. So we're always looking for something x squared or variable squared plus or minus something x plus or minus a constant equals 0. Now it is possible that the b value or c value will be 0, so we got to watch for those. But a must always be something other than 0, or we don't have a quadratic equation. So those are some things to pay attention to, but we want to first make sure that it's written in standard form. Step 1. Okay, step 2, identify the a, b, and c. Okay, we did that a little bit in the last lesson, but we'll describe it again here. Step 3 is to substitute those numbers for a, b, and c into the formula. And then I'm going to break simplify down into 3 steps itself. So step 4, we're going to simplify the discriminant. So that is the b squared minus 4ac part of the equation. It's all of this that's under the radical. And when you simplify that, don't put the radical symbol in your calculator. We're just looking for the number that belongs under the radical. So that's step 1, or of simplify. Step 4 in our overall process. Okay, after you simplify the discriminant, our step 5 is going to be simplify the radical. So you're going to get to a place where you have the square root of some number. Go ahead and simplify that number. See if you can get rid of the radical symbol. See if you can pull anything out of the radical, right? If there's a negative number, then you can at least get an I out front. But that's the second step in simplifying. You want to simplify the radical. And the final thing is to simplify the answer. And most of these have that type of problem. Okay, so let's work through these example problems and see what we get. Now, because I've written some stuff down into example 2, I'm going to erase it, but hopefully you had stuff on your paper for writing what you needed to there. Okay, let's begin. So, example 1 is, our first step is to write it in standard form, and I can see that this is not in standard form. I have my quadratic term over here. Linear term is missing, that's okay. Constant, but over here, not 0. We've got our linear term there. So I'm going to move that from the right side of the equation by subtracting 4x. That will be 0 now. Now, which term should I subtract it from over here? The x squared or the negative 9? It's a trick question because it's neither of those. Instead, what we're going to do is make a third term all by itself. Okay, so I'm going to put it in the middle, and that way I'm thinking about standard form having the quadratic first, then the linear term, then the constant equals 0. So I'm checking to make sure that my exponents are descending, right? Second power, first power, nothing's written. 0th power doesn't even have a variable written there. Okay, step 2, identify A, B, and C. So in this problem, now that it's in standard form, I can see that A, which didn't have anything written, is 1, B is -4, and C is -9. Step 3, plug it in to the quadratic formula. So I'm going to use parentheses everywhere that there's a letter. So as I'm thinking through this, I'm putting parentheses in all of these places. It is especially important on this one, otherwise your calculator may misread, especially if B is negative. So I think it's a good practice to put parentheses around every letter as you go. So that's what I'm going to do. So I'm going to sing the song as I go too to help me remember how this works. So I have x equals negative b. Since b is -4, I'm going to put -4 in that parentheses. Plus or minus the square root of b squared, b is -4, minus 4ac. Since a is 1, that will go there. C is -9, that will go there. All over 2a. And we said that a is 1, so that will go there. Okay, that was step 3. Let's move on to step 4, the first of our simplifying. We are going to find what the discriminant is. So again, the mental math is good here, but also check with your calculator. It's really easy for students, or anybody actually, to make errors here. So I think we're going to do, let's see, 16 plus 39. I think it's going to be 55, but let me follow my own advice and put this in the calculator just to make sure. Oh, yeah, I got 52. Minus 4 times 1 times -9. I'm going to double check that. Minus 4 times 1. Yep, 52. I'm going to go on 36. 16 plus 36, 52. Yeah. See, good thing I checked. All right. So x equals -4, that's +4, plus or minus the square root of 52, all over 2 times 1, that's 2. Okay, so in addition to simplifying the discriminant, when I rewrote this, I simplified this portion, simplified that to kind of get rid of the parentheses along the way. The next step in simplifying is to simplify now the radical. Okay, so the square root of 52, I know 52 divides by 4, 4 and 13, and since the square root of 4 is 2, then what we have here is, x equals 4 plus or minus 2 root 13 all over 2. Okay, notice that each of these elements are even, right? We have 4, we've got 2 root 13, and 2. So I'm going to divide each of them by 2 to finish off my step of simplifying. So 4 divided by 2, that's 2. 2 root 13 divided by 2 is 1 root 13, or I can just write square root of 13. 2 divided by 2, that's 1. I can put this whole thing over 1, but when we've got a number over 1, it's just the number, right? 5 divided by 1 is just 5. So I can just write it without the 1 altogether in this case. So here I have 2 answers, 2 plus the square root of 13 and 2 minus the square root of 13. These are both they are real solutions. Real solutions. Our discriminant is positive. Okay, let's try another one. Okay, example 2. This is not yet in standard form. So you may want to pause here for a second and see if you can move it into standard form. I'm going to subtract the 4x. Since this is quadratic and a linear term or a constant term, I don't have a linear term to subtract it from. So I'm going to write it really small in the middle because I want it to go there. Then I do have a number 5 without a variable, so I'm going to subtract that from its like term, the 9 that doesn't have a variable. So now in standard form, I have 5x squared minus 4x plus 4 equals 0. Once it's in standard form, now I can identify A, B, and C. So I know that A is 5, B is -4, and C is 4. Step 1, put it in standard form. Step 2, write A, B, and C, or identify A, B, and C. The next one is to plug it into the formula. So we have x equals negative b, since b is -4, that's what goes here, plus or minus the square root of b squared minus 4ac. A is 5, c is 4, all over 2a. A is 5. There we go there. Okay, it's always -4. I've got students asking me that sometimes. Yes, that's part of the formula. This -4 shows up, so that's going to happen every time. And we're going to divide by 2a. Those two numbers are always there, always part of the formula. Okay, so let's start by simplifying the discriminant, or all this stuff under the radical. I'm going to try my mental math again, see if I can redeem myself. So here we're going to have 16 for this first part. -20 times 4, -80. 16 minus 80, I think that's -64. Let me plug it in my calculator to check. -4 times 5 times 4, -64. So I'm going to simplify this as I go. -4, that's +4. Plus or minus the square root of, we said -64 was what we got there. And then 2 times 5, that's 10. So my new denominator is 10. The square root of 64 is 8. The square root of -64 then is 8i. Okay, so each of these elements are even. So I know I can divide them by 2. I should check and see if I can divide them by something higher than that. Can I divide all of these terms by 4? The top two, yes. The bottom, I would get a decimal if I divide 10 by 4. So let's go ahead and just divide each of the parts by 2. So 4 divided by 2, that's 2. 8i divided by 2, that's 4i. And 10 divided by 2 is 5. Okay. Looking at example 3, I recommend that right here you pause the video and you try this one by yourself. Okay. You may want to then, as you start looking at it, verify that you've got your A, B, and C correct, because there's a slight trick here. Notice that we just have 2 terms, so something is going to be 0, either A, B, or C. A is the quadratic terms coefficient, B is the linear terms coefficient, and C is the constant. So the quadratic term is 9x squared, so the coefficient there is 9. Linear term is missing. We don't have anything x, right? That's gone. So B is 0 for this problem, and C is -25. If you made an error there, go ahead and pause here and see if you can do the rest of it now that you know your A, B, and C. Okay, next step, plug it in. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I'm going to start by simplifying the discriminant. Without the radical sign, I'm going to put that in the calculator. This is minus any of the signs that are in the parentheses with negative or something, like this one. It's going to be negative, but this one right here is -4 when you put that in the calculator. So we have 0 squared minus 4 times 9 times -25. These two together are 100 times 9. I think we're going to get 900 out of this. I'm going to follow my advice and put it in the calculator because everyone can make an error sometimes. Yep, 900. -0, by the way, is just 0. 0 plus or minus something is just the plus or minus something. So I'm going to get rid of that 0 out front and say plus or minus 900 all over 18. 900 is 30 times 30. So I have a perfect square root. Plus or minus 30 over 18. Now, if there were something in front of that besides 0, then I would at this point write it in two different ways to simplify all the way to the end. But since there's nothing in front of the plus or minus, I'm just going to simplify 30/18. I can divide 6 away from the numerator and denominator, and I'm left with plus or minus 5/3, and that's our answer there. How'd you do? Okay, we have one more example to try together. This one's already in standard form. That's nice. So we can identify A as -3, B is 8, C is -7. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, simplify the discriminant. I'm going straight to the calculator instead of even trying mental math here. Oh, which I should do because you make errors sometimes. Before I hit enter, I'm going to try this. So 64 is 8 squared. -4 times 3, that's positive 12 times -7, that's 70, 84. 64 minus 84, I think I'm going to get -20. I did. Okay. The reason why mental math is good is because we can also make mistakes with our calculator, so you want to maybe check both of them. Okay, negative parentheses 8 is just -8, plus or minus the square root of -20, all over, this is -6, right? 2 times -3. Okay, now we want to simplify the radical if we can. Since 20 is divisible by 4, which is a perfect square, we're going to have 2 root 5, but because it's negative, we're going to have 2i root 5, right? The negative under the radical, we can simplify that by bringing an I out instead, all divided by -6. Now, not only can we divide all of these terms by 2, well, it's technically one term, but each part of the term by 2. Because the denominator is negative, I want to divide by -2 so that our denominator will be positive. So if I take -8 divided by -2, I get positive 4. If I take -6 divided by -2, I get positive 3. Now something unique happens here when I divide by -2. If I have positive 2i root 5 divided by -2, those two cancel out, but I got negative now, so it's -i root 5. But let's look at the other situation. If I have -2i root 5 divided by -2, these two cancel out. Their negatives are also canceling out, so in this case, I get positive I root 5. So look what happened when I divided by a negative. I still get a positive and a negative solution. So it sort of feels like it didn't change anything at all in that part. So it was plus or minus before. We really have those two situations again, plus or minus. When I very first started teaching, I would write it as minus plus, but that was too confusing and not worth it. So 4 plus or minus I root 5 all over 3. I'm going to try one problem from the worksheet with you because it behaves a little bit differently than those that we've seen so far. So let's try number 2 on the assignment together. Number 2 is not yet in standard form, and that's the first step of what we're going to do. So I'm going to subtract 3. This is a quadratic term, a linear term. This is a constant, so I don't have anything to subtract it from. So I'm going to just kind of write it really small over here, minus 3. When I rewrite it, I'll have -2x squared plus 7x minus 3 equals 0. So now I've got 3 terms at trinomial. In this case, A is -2, B is 7, and C is -3. So let's plug it in. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, simplifying the discriminant. 7 squared is 49. -4 times 2, that's 8. Times -3, that's -24. Are we going to get -20 again? I feel like I've made an error. 7 squared, that's 49. What was I doing? 49 minus 24, that's going to be 25, right? Let's see. 7 squared minus 4 times -2 25, yes. So x equals, simplify that, negative 7 plus or minus root 25 all over negative 4. Square root of 25 is 5. So now I have x equals negative 7 plus or minus 5 all over negative 4. Notice that the radicals are all gone. No radical symbols left. And we don't have any I anywhere. So at this point, we can simplify each one, but they're going to be quite different from each other. So now I'm going to separate the plus or minus. So first I'm going to deal with negative 7 plus 5 over negative 4. What do you think is the other one we're going to work on? It's going to be negative 7 minus 5, right, over negative 4. So we're dealing with two situations because of that symbol right there. Okay, so up here, negative 7 plus 5 is negative 2. Negative 2 over negative 4. That can simplify to be positive 1/2. And down here, negative 7 minus 5, that's negative 12 divided by negative 4. Negative 12 divided by negative 4, that's positive 3. So see how these are completely different from each other? They're not plus or minus something. They're two very distinct numbers. When does that happen? When all of the radical symbols go away and we don't have any I anywhere, that's when I want you to write it in the two different ways because you'll get two very distinct answers. All right, happy working. See ya.